Hey guys, happy Tuesday and welcome back to science class. So today we are going to start the fifth chapter in our astronomy unit on the moon. I won't be giving you back your interactive notebooks probably till Thursday because I'm taking time going through them all. So we'll be doing some different activities and I'm assigning a little mini project, which I'll talk more about in another little short video. So to not make this too long. So hopefully you've already printed out your notes. It's just 2 pages on the moon. We're not going to do all of it today. We're going to do the first page. We're going to go through the phases of the moon, and we'll wait and talk about tides on Thursday. I love studying the moon. It's really very interesting. So to start off with, we've got these questions I want you to kind of think about. Think about everything you've already learned about the moon. You started learning about it, I know, in first grade. If you were with me, we talked about it way back then. And then you've talked about it probably again in second and third, and each year a little bit more about the moon and the phases of the moon and, just things you've read and seen over the years. So I want you to think about what you already know and write these down in your notes. You might have to pause the video here in just a second. But what do you think? What do you think the moon does for us? Okay, so these are not, you're not going to get them wrong. I mean, you might be wrong, but it's like, everybody just chill. I just want you, what do you think? And then hopefully by the end of this unit on the moon, you may go back and be like, oh, I thought this, but what I actually learned was this. So what does the moon do for us? If you think, does it do anything for us? Is it just this ball of rock in the sky, or does it have a purpose? Why is it important? If it does do something for us, why? Does it do anything important? Do you think there'd be a difference if we didn't have a moon? What would happen if we didn't have a moon? And then how do you think the moon formed? Like, where did it come from? We know God created it. But any ideas on whether or not, well, anyway, I don't want to give any information away yet. These are just, anyway. All right, I'm going to skip ahead. So if we had no moon, I basically want you to just keep all these questions in mind as we go through the lesson, and then we'll revisit them when we're done talking about the moon. Okay, so here's some moon stats, which is short for statistics, just some general knowledge about the moon. We know it's a big ball of rock. The average distance from the moon to the Earth, as you can see here, is 384,404 kilometers. This is what you're writing in on your notes, which is approximately 239,000 miles. It's like 238.9 something, whatever. I just rounded. So it's approximately 238,000 miles. It's pretty far, just to the moon. That's the closest thing to us. The diameter of the moon, which, remember, when you're talking diameter, you're going distance across. If you have a round object, the distance across, the diameter, is 3,475.9 kilometers. It's about 27, little more than a quarter of the Earth's diameter. So if here was the Earth, the moon would be about a quarter of it. If you were, you could probably line up about 4 moons across the diameter, approximately. The mass of the Earth, remember, mass is going to be kind of related to like weight. How dense is it? So it's only 1.23% of the Earth's mass. So the moon is not very heavy in relation to the Earth. And then the volume is more about the amount of space it takes up, like if it was a 3D container. So it's only about 2% of 2.04% of the Earth's volume. So the Earth is clearly much larger. Just some interesting statistics. So the orbit of the moon takes about this. I've seen so many different things that say the orbit takes 28 days, 27.3 days, 29 and a half days. Like, it's so weird how it's different everywhere, but it's not. And anyway, so for these purposes, we're going to write down the 23.7. But you're going to hear on some of the other teachings that they'll say 28 or 29 and a half. And I'm not quite sure why all that varies. But it is going in an elliptical orbit around the Earth. Okay. And we're going to talk about today, what does the moon have to do to the Earth? I mean, what is its relationship with the Earth, and what are the phases? What causes the phases? So we know that as it's also orbiting around the Earth, it also is rotating. So remember, rotating is something that is just turning, right? Like the Earth is turning. Okay, so not only is it orbiting around the Earth, it's also spinning or rotating, right? Kind of like if you're riding a ride at Six Flags, not only is it going around, your car is spinning. Anyway, so to always think of. So in order to, so interesting, we always see the same side of the moon. So like, see where this little arrow is? Imagine if this was like a little man standing there. Now the man, as the moon is orbiting around the Earth, it's rotating because at this point, the little man, imagine this is a little man, is standing on the left side of the moon. But over here, the little man is standing on the bottom of the moon because the moon has rotated a quarter of a turn. So we're still seeing the same side of the moon. Now the moon is going to slowly rotate another quarter of a turn. And so the man on the moon, is still facing us. And then the moon rotates one more quarter. And again, man on the moon is still facing us. And then it rotates again. So it takes one complete orbit, okay, which is like about 28 days. And I said 27.3, 28, something like that. 28 days. In that 28 days that it takes to go all the way around the Earth, it only rotates once. Did you catch that? That's really important. You might add a little note here. There's not a place for it in the notes. I should have done that. But in the time that it takes for the moon to completely rotate one time is the same amount of time it takes to go all the way around. So you could say, and this question will come up later on your little mini moon project, the moon has the same day and the same length of time is a day on the moon as a year. Okay, let me say that again. But let me see if the question is again. The question that you're going to have to answer later says, what does it mean when we say that a day and a year are the same on the moon? So think about it. For us, a day is one complete turn, right? 24 hours, one complete turn. And then a year is all the way around, which is 365 days, right? But for the moon, it's all the way around year, right? In that amount of time that it's going all the way around the Earth, which you could call it a year, it's also turning one time, which is what we also call a day. So kind of, I don't know if that made any sense. It's really hard to not act this stuff out with you guys, but we'll come back to this. Okay, so, oh good, I moved it enough. Had to move a bunch of stuff over so my face wasn't blocking things. So again, imagine this is the man on the moon. He's standing here, these little arrows. The rotation of the moon, basically it's locked by gravity to the Earth. Okay, that's why it doesn't float off into space. So its period, and this is what I just said in the previous slide, or a day, is the same as its orbital period around the Earth. So its day, the amount of time it takes to go one time around, like our Earth takes 24 hours to go around one time. The amount of time that it takes to turn all the way around is the same amount of time that it takes for it to go all the way around the Earth. So it's rotating as it's orbiting around, and it's the same period of time to rotate once as it is to orbit. So that's why they call them the day and the year the same. Okay, let's see here. Okay, so because of that, we can only see this side of the moon. We always see it from Earth. Every time you're looking at the moon, you're always seeing the same exact side. We never see this side of the moon, okay, unless we launch a rocket, go past the moon, and look back. We don't see that side of the moon. So you guys won't see it unless you see a picture. So sometimes people will call that other side of the moon the dark side of the moon, but it's really not the dark side of the moon, and I'll explain. It actually gets just as much light as the near side. So this is just a silly graphic. There's the moon, there's the dark side of the moon. Ha ha ha, for all you Star Wars fans. So the far side gets just as much light as the near side, and I'm going to explain that in a picture. Matter of fact, during new moon, we don't see the moon at all, but the whole other side or the whole far side of the moon is completely lit. So calling it the dark side, you hear people say the dark side of the moon all the time, but it's really not the dark side. It's the far side. It's the far facing away versus the near side that we see. Okay, so since we're always seeing the same side of the moon, the far side must receive the same amount of sunlight as the near side. And I know that this is a really, really cool graphic. I really should have printed it and put it in your notes. I should have cut and pasted it and put it in your notes, but it's a lot of ink and I didn't want to have y'all do that. But okay, so look at this down here, this little key. You've got the far side is being represented by the green lines, and then the dark side is the side that is actually facing away from the sun at the moment, right? No, I'm sorry. It's the side that we can't see. It's the part that we can't see. So if we're standing right here on Earth and we're looking at the moon, this would be a full moon. We see all of it lit up, and the far side is now dark, and it's on the other side. But then as again, we're standing right here, we're still seeing the same this when you think about the near side and the far side, think this little orbit line going around it is cutting it in half. Don't think of this line. This is cutting it in half. This is what we see. We see this. This line's cutting it in half. We see this little sliver. So right now, if I'm standing right here on Earth and I'm looking straight on, I'm seeing this part is illuminated. This part is dark. Okay. And then the far side is got a little light on it. This part's still dark. So look at 6 over here. Wait, this is 6, right? Yeah. So, oh no, 6 was the full moon. I think these are numbered wrong. There they are. Because this should be 6, the full moon. This should be 7. That should be 7. Oh, I wonder if I messed it up when I moved it. Anyway, okay, so this is going to be 7, and it's got a little bit of shade showing or darkness, and then this is the part that's illuminated. Then this should be 8. If I'm standing here on the Earth and I'm looking straight on, I see half of the moon is lit up, half of it is not lit up, but the far side, half of it is lit up and half of it is dark. And this is what we're seeing on Earth. We're seeing half lit, half not lit. So again, it's not the dark side, it's the far side because part of it is lit up. Then when you get to this, which would really be this one, oh, the numbers are, oh, okay, this is 1, this is 2, this is 3, this is 4. Okay, I'm a dork. Okay, so this is 8. The numbers are just not lined up. I think I scooted the picture and I messed up the numbers being lined up. So this is 8 over here. So 8, when I'm standing here, I'm seeing mostly dark and I'm seeing a little sliver of light, but the far side of the moon is almost completely lit up. So again, it can't be the dark side. And then the last phase over here, which is new moon 1, when I'm standing here on Earth and I'm looking, all I see is dark. I can't, basically a new moon, you can't see it. It's like there's no moon in the sky, according to our eyes, but it's there. We just can't see it because we're now seeing the dark side. And the far side of the moon is completely lit. So we're going to watch some different videos that show this, but I think it'll make more sense. So basically the near side of the moon is what we see. The far side of the moon is what we don't see. Okay, so don't call it the dark side because it's not the dark side. All right, whoa, that's going to give you like a seizure. So don't look at it too long. Okay, what causes the phases of the moon? Okay, so this is a really, really good video, but instead of playing it now, because it's about 5 minutes, I'm just going to link it after this video, and I want you to go back and look at what causes the phases of the moon. It's a really, really good video. We watch it every year in class and pause it, talk about it. We just can't do that together this year. So, pause it, talk about it with your mom or a sibling or something if you can, but it's a good video that I think will help you understand the phases better. But you're going to be writing down, a common misconception is that it's a shadow. It's not a shadow on the moon. The moon doesn't make any light of its own. It reflects the light from the sun. And sometimes we just can't see all of the reflecting light because of where the angle we're looking at it from. It really is all about the angle that we're looking at the moon from, that we can't see everything. Okay, you know that sometimes things are out of your sight and you can't see it from the angle you're looking at. It's the same thing with the phases of the moon. It's all about the angle. It's not about whether it's got a shadow on it. So the phases of the moon are a result of the changing viewing angles throughout the month because it's moving, we're moving, and we're going around the sun. So there's lots of things moving. Lots of moving parts. Okay, so here's another example. Again, these are some really great pictures that I probably would have printed out and given to you if we were in person, but I don't want you to have to use all this ink. If you have a phone, you could take screenshots of some of these really good photos from the videos or anywhere, or an iPad, or just take a screenshot on your computer because these are really good. Again, here's a little dude standing, there's you standing on the Earth, and it's starting with a new moon. Sometimes it starts with a full moon, it just depends. It's starting with they flipped it. The sun's on this side. So when we're standing here looking at the moon, the new moon, again, this is the far side. but it's not it. Well, I shouldn't say far side. It's not the dark side of the moon. It's the far side because look, it's completely lit up. The sun is shining on it. But because of where we are on the Earth and the angle, all we can see is the part that isn't reflecting light right now. Because the part that's reflecting light is facing away from us. So that's what we see right here, new. Then as you get to A, the waxing crescent, we still see mostly dark, but we see a little sliver of light. So it looks like this, the waxing crescent. When you get to the first quarter moon, we see half the dark and half the light, which is why it looks like this. Then we get here, we see a lot more light and a little sliver of dark. So it's your waxing gibbous. Then once we're here on the Earth, we see all of this illuminating because now the sun is shining directly onto this side that is facing us. And it's a full moon. Okay, then as it starts to change its angle again, we're seeing mostly light, a little sliver, which is going to be this is the little sliver of dark, the waning gibbous. Then again, we're at third quarter, which is half and half. And then the waning crescent, again, we see this little sliver of light. We see mostly dark, and that's what it looks like right here. And then it starts back over with a new moon. This whole thing takes about 2 weeks. Okay, so about every 2 weeks, you'll see another full moon. And I'm going to have you guys track that. I'm going to have you, well, I'll explain it. I'm almost to the end. I'll explain it in a second. Okay, what else did I want to say about this picture? This is such a really good picture. I feel like I'm forgetting something. Oh, so the other things that I want you to be mindful of, and we'll be practicing this all of this week, so I think you'll get the words down, is waxing when it always starting from new moon, you can't see it. And there was this movie that came out like in the, I don't know, 80s or 90s. I don't remember. Probably the 80s. I don't know. Ask your parents. They know. The Karate Kid. You guys may have heard of the Karate Kid. Maybe not. I'm talking the original Karate Kid, not the remake several years ago. But whenever his karate instructor was teaching him he was supposed to be teaching him how to do karate, but he was making him wax all of his cars. And he kept telling him, wax on, wax off, wax on, wax off. And it was this goofy wax on, wax off, but really he was trying to teach him these karate moves. Anyway, so I have always remembered wax on from Karate Kid. It helps me think of them when it's a waxing moon, the light is coming on. It's starting at the new moon and it's slowly, here's a little bit of light, here's a little bit of light, here's a little bit of light. Now it's full. So these are all waxing because they're waxing on. That's just my goofy little thing to help you remember it. Hopefully it helps you remember it. This is called first quarter because remember I told you it takes 2 weeks to get to the full moon. So it's 1 week to get to the first quarter. That means the moon has gone 1 quarter of a way around. Remember, we divide things into four quarters as a whole, right? So 1 quarter around is first quarter. Halfway around, we don't call it a half moon, it's a full moon just because of the angle we're looking at it. 3 quarters of the way around is the third quarter moon, and then full all the way around again is the new moon. Okay, remember, wax on, wax on. Okay. Oh, there's words here. I probably already said all of this. We can only see the part of the moon which had been lit up by the sun. And then the part that's lit by the sun is facing, at a new moon, it's facing away from us. So we really can't see it. I don't really like the way that worked out. We can only see the part of the moon which has been lit up by the sun. It's partially lit by the sun. It's facing away from us at new moon. Okay, remember here's new moon. The part that is lit, not partially. The part lit by the sun is facing away from us at a new moon. We really can't see it. And that's it right there. I completely forgot I had all this. And then at the full moon, the part that is lit by the sun is facing towards us, and we see the whole thing, which is over here, the full moon. Okay, so in between us is the result. Oh, the little red lines went away. Okay, everything in between is the result of us seeing a portion of the lit side. Okay, sorry, the word portion got cut off, and I know you need to write this down. So everything in between is the result of us seeing a portion, you're just missing the I-O-N, of the lit side, portion of the lit side. Okay, so we're just seeing a little portion of it as it's going around. Okay, again, this is just another really good illustration. You might want to take a screenshot of it or take a picture with your phone if you'd like to, but it corresponds with, again, here's your full moon, that's 5. As we're standing right here on the earth and looking, we're seeing 6. We see the little bit of the darkness coming. Half of it's dark, more dark, completely dark. A little light starts to come back on 2. The waxing crescent, the first quarter moon at 3. the waxing gibbous at 4, and then back to a full moon at 5. So you really need to learn those phases, but I'm going to give you some more information on that. Okay, we're going to stop here. Okay, so you should have gotten your notes through the phases of the moon. After this, I would like you to watch the phases of the moon video, and you might take a few more notes in your on your piece of paper on your paper notes, just about the different phases. I would write them down, starting with full. Then you go to waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent, new moon. I was trying to remember. So you might want to write those down while you're watching the video. Just add those to your notes. I meant to put a place in your notes and I forgot. So please do that. And then after that, there's one more short video where I'm going to explain your little project that you're going to be doing for the moon for the next couple weeks. All right. Hope you guys enjoyed science class today. And I will see you back on Thursday. Actually, watch the other video of me today. All right. Bye.